The number of free electrons. Show that the number of free electrons in a given system is related to its Fermi energy by capital N equals 8 pi V volume divided by 3 h cube, Planck's constant cube, 2m to the power 3 over 2. M is the mass of the electron, E Fermi, Fermi energy to the power 3 over 2. So let's recall that the number of electrons in the Fermi sphere is the volume of the Fermi sphere, which is 4/3 pi Fermi wave vector cube divided by the unit volume per state, 2 pi over the volume cube, multiplied by 2, because for each state we have spin up and spin down, so we have spin degeneracy. All right. So the unit volume in the Fermi sphere is where we can have one state, delta kx times delta ky times delta kz. It is 2 pi over Lx times 2 pi over Ly times 2 pi over Lz, the length in the z axis. So this is basically 2 pi cube divided by v. Remember that we have obtained this condition, k is 2n pi over L, by using Born-von Karman periodic boundary conditions. Okay, so the total number of electrons in the Fermi sphere, capital N, is 4 over 3 pi kf cube multiplied with, so this so here is a mistake, so this is 2 pi parentheses cube divided by v, right? So because we have delta kx times delta ky times delta kz is given this way. So this v goes upstairs, divided by 2 cube, 8 pi cube, multiplied with 2. Okay, so we see that we have a 2 and a 4, which makes an 8, so this 8 disappears, and this pi cancels one of the pi's downstairs, so this is going to become pi square. So with that, we have capital N equals the number of electrons, v times Fermi wave vector cube divided by 3 pi square, so that the Fermi wave vector is basically 3 pi square n to the power 1/3, where n is now the number density, total number of electrons per volume. Now, recall that the Fermi energy is related to the Fermi wave vector for the free electron, h bar square kf square over 2m. So h bar is reduced Planck's constant, h divided by 2 pi. So with that, the Fermi wave vector becomes, in terms of the Fermi energy, square root 2m Fermi energy divided by h bar. So we have capital N, the number of electrons, equal to v over 3 pi square multiplied with Fermi wave vector cube, you can see here. So for Fermi wave vector, we can substitute square root 2me Fermi over h bar, and we have to take the cube of it. So we will have h bar cube at the bottom, and 2m Fermi energy to the power 1/2 to the power 3 becomes 3 over 2. So this is going to be V divided by 3 pi square. Now we have h bar cube. H bar is h divided by 2 pi. So that is 2 pi cube divided by h cube, Planck's constant. And then we have 2m to the power 3 over 2. And then we have Fermi energy to the power 3 over 2. So this is going to become the volume V divided by 3 pi square multiplied with 8 pi cube divided by Planck's constant cube multiplied by 2m to the power 3 over 2 E Fermi to the power 3 over 2. Now we see that this pi square will make the pi cube upstairs pi. So it will get rid of this 3. So finally we will see that the number of electrons is 8 pi V divided by 3h cube 2m to the power 3 over 2 Fermi energy to the power 3 over 2. So this is basically what we were asked to show. The number of electrons in a given system is related to its energy by this relationship. So how did we go about this problem? The number of electrons in the Fermi sphere is number of states in the Fermi sphere multiplied by 2, because for each state we can put 2 electrons spin up and spin down, which is what is the maximum allowed by the Pauli exclusion principle. Now, what is the number of states in the Fermi sphere? The volume of the Fermi sphere, 4/3 pi kF cube, divided by the unit volume where we have one state. And since k values are 2n pi over Li, where I is the dimension x or y or z, we have 2 pi cube, 2 pi parenthesis cube over V for the unit volume where we have one state. So the number of states, 4/3 pi kF cube divided by V over 8 pi cube multiplied by 2 gives us V kF cube over 3 pi square as the number of electrons. So number of electrons is related to the Fermi wave vector as kF equals 3 pi square n to the power 1/3 and is capital N over V, the number density of the electrons. Now the Fermi energy is h bar square kF square over 2m. So the Fermi wave vector is square root twice mass of the electron Fermi energy divided by h bar, where h bar is Planck's constant h divided by 2 pi. So if we substitute this Fermi wave vector into this equation, V over 3 pi squared times kF cube is V over 3 pi squared times 2m E Fermi to the power 3 halves divided by h bar cube. Then we substitute h bar as h over 2 pi. We obtain our final result after the simplifications, 8 pi V over 3h cube, 2m to the 3 halves, E Fermi to the 3 halves. That's exactly the given equation.